684. On their team test, Raymond, Sarah, Hannah, and Aiden were given y equals 4x squared minus 24x plus 7 to change into graphing form. Raymond noticed that the leading coefficient was 4 and not 1. His team agreed on a way to start rewriting, but then they worked in pairs and got two different solutions, shown below. See, this is one, this is the other. We'll look at them in a second. Hannah says, Aiden and Sarah made a mistake in step 3. Because of the factored 4, they really added 4 times 9 to complete the square. So they should subtract 36, not just 9. Is Hannah correct? Justify your answer by showing whether the results are equivalent to the original equation. Alright, so they're saying that Aiden and Sarah made a mistake. They said they made a mistake right here in step 3. They said that they should have really been subtracting 36 here. Okay, why subtracting 36? Well, they said that because they're taking the 3 here, which becomes 9, and they're multiplying it times 4 to get 36. Let's see if Raymond and Hannah are correct. I know that this is something that, for some reason, there wasn't much practice on beforehand. So let's go ahead and just work this out and compare so that we all understand the process of what's going on. And then I'll show you a second way that you can justify it here. So our problem is y equals 4x squared minus 24x plus 7. They're wanting to complete the square here, but this is a little bit different than the way that we did it before because we have a coefficient in front of x squared that is not equal to 1. So we've got a 4 here. So both groups seem to be correct here in that they looked at this part of their expression right here and they said, I'm going to factor out a 4. So they're taking it here, and we've got y is equal to, because 4 goes into both of these, but we definitely just want to take it out because this one has the 4. We want that to end up being 1. So we've got this 4 here. And when we factor out that 4, that would leave us with x squared minus 6x. And then we have plus 7 out here. Now this, we need to turn into a perfect square trinomial. So we're going to have to add something in here. Let's rewrite this now as y equals, and I'm going to go ahead and still keep it color-coded so we can see what's going on. We've got 4 times the quantity of x squared minus 6x plus blank, and then we should have a plus 7 out here. So what value do we have to add here to x squared minus 6x plus blank here? So what value do we have to add in here to complete the square of this trinomial? Well, remember, if we took our negative 6's and we split them when we were completing the square, that would end up being 3x and 3x, which means that we would have to add 9. So half of 6 squared, this should equal half of 6 squared here. So 6, let's just do it over here rather than just trying to describe it. If I take half of 6 and then I square it, I should end up with 9. So that's the value we want to add in here to have a perfect square trinomial. So we're going to add 9 here. And I think this is where the issue comes into play for this team up here. Remember, if you add 9 to one side of your equation, thinking about this entire thing as an equation, if I add 9 here, normally we also have to add 9 to the other side. But I think what Hannah is saying in her argument there, they said because they factored the 4, they really need to add the 4 times 9, right? We're adding 9 here, but how many 9s are we really adding? We're adding 4 9s. So we're really adding how much? So over here, we're going to have to add 4 times 9, which is 36. So we've got really 36 over here, 36 plus y, and I know this is a little bit different than the way they did it up here, but this is the way we did it, so I want to make sure that we're all on the same page. So 36 plus y equals, we've got 4 times, and remember we added the 9 in here so we could factor this and make this times the quantity of x minus 3 squared plus 7. So as we look here, I think that we made it this far in this one. Looks like they added in their 3 squared and then added the opposite of it here. The reason where this is coming from is they're taking their 36 and subtracting it from both sides. But over here you'll see Aiden and Sarah aren't doing that at all. They subtracted 9. They subtracted the opposite of this. But they're really adding 4 times 9. So they're going to have to take away 4 times 9. But we don't normally just do it on one side. We take it and we add it to both sides and then bring it back across. So I'm going to go ahead and subtract my 36 from each side. And we'll see here that y should equal 4 times the quantity of x minus 3 squared plus, we'll say 7 minus 36. And what is 7 minus 36? It should be negative 29. So we have 4 times the quantity of x minus 3 squared minus 29 equals y. This is why Raymond and Hannah have the correct answer, and this one is not correct because we have minus 2 left over because they did not take away enough. So hopefully that helps you a little bit here. Just know, if the coefficient is not 1, you're going to have to factor out of this first part here, factor out the 4, complete the square, but when you complete the square, you have to remember you're really adding 9 4 times. Add the same thing to the other side, then isolate y again after you've factored. Now let's just go ahead and check this on the calculator. That's the easiest way to verify whether or not they're equivalent. Okay, because they want us to justify that Hannah was correct. So let's start out with our original equation. Y equals 4x squared minus 24x plus 7. Okay, so we got that there. Now I'll go ahead and let you know that I already adjusted my window. I decreased my y min to negative 30, and I increased my y max to positive 30. So that now when I graph it here, you'll see what I get. My parabola fits on here a little bit better. So what we're going to do here is, if this expression here is equivalent, get my pen back out, if this expression is equivalent here, then it should give us the exact same graph. If this expression is equivalent, and we already know it's not because this one is, this one would end up giving us the same graph. So let's just go ahead and graph those here and see what happens. So I'm going to go down. I'm going to graph the one that's wrong first. Actually, let's confirm the one that's right. Let's do 4 times the quantity of x minus 3. Let's close it, let's square it, and then let's take away 29. And then I'm just going to change my color real quick because I think it's hard to see yellow on the screen. There we go. Blue will be nice. Let's do that one there. So when I graph this here, it should go directly over top our other parabola, and you see it did. That's how we know that that is equivalent. Now if I want to see that this one's not, let's go into y equals. Let's go down to the third function here, and let's type in what they got as an answer. 4 times the quantity of x minus 3. We're going to square it, and then we're going to subtract 2. Obviously this is going to be different than this. Let's take a look and see. And there it is. So if it's equivalent, it's going to have the same graph. In this case, what they got as an answer does not have the same graph. This is a tool that you can use when you're taking tests or working on problems. If you're trying to simplify something, graph the original, graph your answer, and if they're truly equivalent, you should get the same graphs. Hopefully this helped you out there. This is problem 6-84. I'll leave you to write your own response there. This should be more than enough information to help you with that.